They called it a mercy weapon. One beam, 1 millisecond, you never even felt it coming. The Xylos Empire had spent 3,000 years perfecting the art of impossible precision. And humanity had exactly 0 answers, until the day a crinkled roll of kitchen foil changed the entire course of galactic history. If that sounds insane, good. Hit like, subscribe to HFY Endurance Tales, and drop a comment below because you are not ready for what comes next. Let's go. Nobody on Earth believed it at first. Not the generals, not the scientists, not the politicians who had spent the better part of 2 decades arguing about climate policy and healthcare budgets, while the rest of the galaxy quietly went dark. The signals had been coming in for years, deep space observatories picking up distress calls on frequencies humanity barely understood. Whole star systems going silent, one by one. Like someone was walking through a crowded room and turning off the lights. Commander Daniel Reeves had read every single intercept report, and every single one made his stomach turn. He was 51 years old, a career military man out of Colorado Springs, with a jaw like a steel beam and eyes that had seen too much to be surprised by anything. Or so he thought. He had commanded 3 carrier strike groups, survived a bilateral collapse of the Pacific Fleet's communication grid during the Shanghai crisis of 2021, and personally overseen the decommissioning of America's last nuclear submarine program when the new energy treaties came into force. He was not a man who scared easily, but sitting inside the Joint Command bunker beneath Peterson Air Force Base, staring at the latest intercept from the Deep Space Listening Array. Daniel Reeves felt something crawl up his spine that he hadn't felt since he was a kid standing in the dark at the top of the stairs, certain something was waiting at the bottom. The Xylos Empire had made first contact 14 months ago. Not in the gentle, optimistic way science fiction writers had always imagined. No slow approach, no radio signal, no blinking lights over a cornfield. They announced themselves the way a thunderstorm announces itself. You don't see it coming. You just feel the pressure change, and then everything goes sideways. Their first message to Earth had been translated in 6 hours flat by an AI system running at the Lawrence Berkeley National Laboratory. The translation was chillingly straightforward. Your territory has been assessed. Resist and you will be processed. Comply and you will be processed. The outcome is identical. The timeline is not. The world governments had tried diplomacy, 3 rounds of it. Each response from the Xylos carried the same cold arithmetic. They weren't interested in trade, culture, or coexistence. They were interested in resources. Earth had them. The Xylos had the means to take them. To the Empire, this was not a war. It was a transaction. The thermal lance was the instrument of that transaction. Colonel Stephen Ward, lead weapons analyst at the Advanced Research Integration Center in Nevada, had spent 9 months reverse engineering every scrap of data the deep space arrays had pulled on the Xylos weapon system. He presented his findings to the Joint Command on a Tuesday morning, and by the end of his first slide, every face in the room had gone completely pale. The thermal lance was not a laser in any sense that human engineers understood the term. A conventional laser operated on coherent light amplification, predictable, linear, based on well-understood physics. The thermal lance operated on something the Xylos called resonant thermal convergence, which Stephen had spent 3 months just trying to find an adequate English phrase for. The closest he could manage was a beam that finds the exact molecular frequency of your target and convinces every atom in it to tear itself apart simultaneously. Standard titanium hull. Plating, the same material used in every warship. Every satellite, every deep space probe humanity had ever built, vaporized in approximately 4 milliseconds. Not melted, not cracked, vaporized. The beam didn't burn through your armor, it simply persuaded your armor to stop existing. And it was guided by an AI targeting system that made humanity's best military software look like a pocket calculator. The Xylos' targeting intelligence, what the analysts had taken to calling the Shepherd, could track 12,000 individual objects simultaneously, calculate energy shield harmonics on the fly, and adjust its beam frequency in real time to punch through any defensive field humanity had yet deployed. It had no blind spots, it had no lag, it had no hesitation. The first field demonstration had come 3 weeks after Stephen's briefing. The Xylos hit the orbital defense platform Endurance 7 without warning. Endurance 7 was the crown jewel of the United Earth Defense Initiative. 6 years in construction, $22 billion. Triple redundant energy shields, rated to withstand a sustained nuclear barrage. The thermal lance dissolved it in 11 seconds. The crew of 43 had no time to react. The distress signal lasted exactly 1.4 seconds before there was nothing left to transmit from. Daniel Reeves stood in the debris field analysis room and looked at the thermal spectroscopy readout for a long time. Then he turned to Stephen Ward and said quietly, "Tell me something useful." Stephen had nothing, not yet. But that was about to change, because on the other side of the country, in a Nevada industrial recycling facility, someone had just made a very strange and very accidental discovery. And it was the kind of discovery that would have seemed completely insane to anyone who heard it secondhand. Which, unfortunately for Daniel Reeves, was exactly how he was about to hear it. The question was whether he'd be smart enough to listen. The supply chain collapse of 2026 didn't happen all at once. It unraveled the way most catastrophes do, slowly, then suddenly, then all at the same time. The Xylos hadn't even needed to fire a single shot at Earth's surface to begin dismantling its industrial capacity. All they had to do was sit in the outer system and wait, and the psychological pressure did the rest. Contracts dried up. Manufacturing plants in Detroit, Seoul, Frankfurt, and Osaka started retooling overnight as governments desperately redirected resources toward military production. The global shipping network, already strained by 2 decades of climate-driven disruptions, began fragmenting under the weight of emergency requisitions and port lockdowns. Materials that had been reliably available for decades were suddenly vanishing off order manifests. Titanium alloys, carbon fiber composites, high-grade electromagnetic shielding polymers. The United Earth Defense Initiative had a problem. It was trying to build warships out of materials it could no longer reliably source, on a timeline that allowed for 0 delays. To fight a weapon it had no defense against. In the Pentagon's planning rooms, people had started using the phrase manufacturing triage. You didn't build what you wanted, you built what you could, and you prayed it was enough. Marcus Holt was not a military man. He was 43 years old, a mechanical engineer from Reno, Nevada. With a degree from the University of Nevada, and a career that had taken him from automotive parts design to heavy industrial equipment repair by a winding and slightly absurd path. Senior engineer at the Cascade Industrial Recycling Facility outside Sparks. Cascade processed everything: scrap metal, industrial equipment, commercial kitchen supplies, bulk food service materials. They had contracts with 36 hotels, 112 restaurants, and the Nevada Gaming Commission's maintenance division. When the government's emergency materials requisition came through in the spring of 2026, Marcus found himself in the unexpected position of being one of the most useful engineers in the state of Nevada. Because Cascade had something that the high-tech defense manufacturers suddenly didn't: stuff. Lots of it, piles of it. Bins and pallets, and entire warehouse aisles full of materials that nobody had thought to classify as militarily relevant, because nobody in the history of military planning had ever needed to. The requisition team from Peterson Air Force Base arrived on a Wednesday morning. 3 officers, 2 materials scientists, and a specialist in electromagnetic shielding named Dr. Carolyn Marsh, who had been drafted from the University of Michigan Physics Department and still looked slightly dazed by how fast her life had changed in the past 4 months. They were there to assess whether Cascade's stockpile of industrial aluminum products could be processed and repurposed for lightweight hull reinforcement. Not a promising lead, honestly. Industrial aluminum wasn't going to stop a thermal lance any more than a paper bag would stop a freight train, but they were running out of leads. Marcus walked them through the facility, explaining the inventory: scrap aluminum beams from hotel renovation projects, surplus commercial-grade aluminum piping. And then, in Warehouse Bay 7, 42 pallets of heavy-duty commercial catering foil, the kind used in hotel banquet kitchens and large-scale food service operations. Sold by the roll, shipped by the pallet, completely unremarkable, completely useless for any conceivable military purpose, or so everyone thought. The discovery happened by accident, the way the best discoveries usually do. One of the Air Force officers, a young captain named Ryan Blake, had been running a handheld laser spectrometry device, standard equipment for rapid materials assessment, along the rows of inventory. He was half paying attention, sweeping the beam across surfaces automatically while Marcus talked. The device emitted a low-power, coherent beam in the infrared spectrum, close enough in its operational principles to a thermal lance to be at least marginally useful for testing reflectivity properties. When the beam hit a partially unrolled and crinkled roll of catering foil that had slipped off a pallet and landed on the floor, something unexpected happened. The beam didn't reflect cleanly. It scattered in 40 different directions simultaneously. The readout on Ryan's device went absolutely haywire. The sensors were picking up return signals from every conceivable angle. A chaotic spray of reflected energy that the instrument's software couldn't make sense of. Ryan stopped walking. He looked at the readout. He looked at the foil. He looked at Dr. Carolyn Marsh. Carolyn was already crouching down next to the foil, her eyes sharp and focused in a way they hadn't been for most of the facility tour. She wasn't looking at the foil as a materials engineer. She was looking at it as a physicist, and what she was seeing made a very specific part of her brain start working very fast. "Marcus," she said without looking up, "do you have more of this?" "In worse condition, more crinkled," Marcus blinked. "We've got a whole pallet of returns, damaged rolls, partial unwindings, stuff the hotels sent back. We were going to process it for scrap." "Don't process it," Carolyn said. She stood up and turned to Ryan Blake. "Get me a direct line to Colonel Ward at ARIC right now." Ryan looked uncertain. "Ma'am, it's just kitchen foil." "It's chaotic reflective geometry," Carolyn said, and her voice had gone very quiet and very precise. "And the Shepard's targeting system runs on predictive coherence modeling, which means—" She stopped. She looked at the foil. She looked at the readout on Ryan's device. And for just a moment, a slow, disbelieving smile crossed her face. "Which means we might have just found the dumbest, most impossible solution in the history of warfare," she said. "And I need to make a phone call." 48 hours later, Colonel Stephen Ward was standing in a test bay in Nevada, watching a full-scale thermal lance simulation fire at a titanium panel wrapped in crinkled catering foil. And he was not blinking, he was not breathing, he was just watching. Because what was happening in front of him was either the most significant military discovery of the century or a very elaborate hallucination, and he genuinely was not sure which. The physics were almost insultingly simple once Carolyn laid them out. That was the part that kept hitting Stephen Ward in the chest, not the complexity of the solution, but the absurd, staggering simplicity of it. The Xylo's thermal lance operated on resonant thermal convergence. To destroy a target, the beam had to find the target's precise molecular resonance frequency, lock on, and sustain that lock for the fraction of a second needed to cascade the destruction through the hull matrix. The Shepard, the AI targeting system that guided the lance, calculated that resonance using a combination of deep spectrum surface analysis and predictive modeling based on known materials. Profiles. It was extraordinarily good at targeting things it understood, things with clean, predictable geometry, things that behaved the way physics said they were supposed to behave. Crinkled aluminum foil did not behave the way physics said it was supposed to behave, not in any useful sense. A flat, smooth surface reflected a coherent beam in a predictable, calculable direction. The Shepard could account for that in microseconds. But a heavily crinkled, irregularly deformed surface, one with thousands of random microfacets at thousands of random angles, none of them uniform, none of them repeatable, reflected incoming coherent energy in a chaotic spray that scattered across the full spatial hemisphere. Every microfacet redirected a fraction of the beam at a different angle. The aggregate result was a diffusion pattern so complex, so geometrically random, that no predictive model could calculate it in advance. You'd have to measure every single microfacet individually, in real time, faster than the beam itself was traveling, which was physically impossible. The Shepherd couldn't lock on to a crinkled surface. It couldn't find the resonance frequency because the surface geometry was too chaotic to model. The beam hit the foil, shattered into 1,000 harmless fragments of reflected light. And the hull underneath, the actual titanium substrate, never received enough coherent energy to trigger cascade vaporization. The foil didn't stop the beam. It confused it. It broke the beam's fundamental operating principle by presenting a surface too irregular to target. It's like trying to hit a mirror that someone crumpled into a ball, Carolyn explained to the gathered command staff 3 days after the initial test. You fire a perfect, precise laser at it, and it goes everywhere except where you aimed. The more precise your targeting system, the worse the problem gets, because you can't predict chaos. You can only predict order. Daniel Reeves had been sitting very still through the entire briefing. He was the kind of man who went very still when he was thinking hard, not slack, not relaxed, just motionless in a way that made the air around him feel slightly denser. When Carolyn finished, he looked at Stephen Ward. "How much foil do we have?" he asked. Stephen checked his notes. "Cascade's inventory is about 19 tons of commercial heavy-duty catering foil. We've already put out emergency procurement requests to every commercial food service supplier on the continent. Current estimate, if we pull from hotel chains, restaurant supply warehouses, and food manufacturing facilities across North America, is somewhere between 800 and 1,200 tons within 72 hours. That's not enough to wrap a fleet," Daniel said. "No," Stephen agreed. "But we've been on the phone with Reynolds Consumer Products, Amerifil, and 3 overseas manufacturers. They can surge production. We can also supplement with any commercial-grade aluminum foil meeting the minimum thickness spec. It doesn't have to be catering grade. It just has to be heavy enough to hold a crinkled pattern under hull-mounting stress." He paused. "The short version, sir, is that we can cover every ship in the 4th Fleet if we work fast enough." Daniel was quiet for another moment. "And the mounting problem?" That was where Marcus Holt came in. He was standing at the back of the room, slightly uncomfortable in the borrowed collared shirt someone had given him, surrounded by more stars and eagles than he'd ever seen outside of a parade. But he knew his stuff and he talked about it clearly. The challenge wasn't the foil itself. The challenge was adhering thousands of square meters of thin, crinkled aluminum sheeting to the exterior hulls of spacecraft designed for high-velocity atmospheric entry and deep space thermal cycling, hulls that experienced enormous temperature swings, significant vibration loads, and the constant low-level stress of acceleration and deceleration. Standard adhesives wouldn't survive the thermal cycling. Standard mechanical fasteners would create stress points that would crack the foil and flatten the crinkled pattern, defeating the purpose. Marcus had spent 48 sleepless hours working through the problem, and had landed on a solution that involved a modified aerospace-grade silicone bonding compound, applied in a specific pattern that allowed the foil to flex without flattening, combined with a laser-perforated backing layer that let heat pass through without building up pressure under the foil. It would work. He was 91% confident it would work. "What about the engine heat sinks?" Daniel asked. "We leave those clear," Marcus said. "The foil goes on the primary hull surfaces, the weapon-facing sides, the dorsal and ventral plates. The heat sinks stay exposed there on the stern, mostly shielded by the engine cowlings anyway. The Xylo's beam comes from the front. We protect the front." Daniel nodded slowly. "And the targeting confusion, does it persist across multiple firings?" "Can the Shepherd adapt?" Carolyn answered that one. "Theoretically, over thousands of firings at the same specific surface, you might develop enough data to begin modeling individual foil configurations. But the key word is specific. The Shepherd would have to learn each ship's foil pattern individually. And if we vary the crinkle pattern between ships, and between hull sections, which we can do simply by using different application crews who crinkle the foil by hand, the Shepherd's dataset never converges. It's always starting over. Every ship looks different. Every section of every ship looks different. It never builds a useful model. So the more random the application, the better," Daniel said. "Exactly," Carolyn said. "The single most effective thing we can do is make sure no 2 sections of foil are crinkled the same way." Daniel Reeves stood up. He looked around the room at the generals, the scientists, the engineers, the terrified and exhausted faces of people who had been running on adrenaline and cold coffee for weeks. Then he looked at the image on the wall display, an artist's rendering of the Xylo's thermal lance, elegant and terrible and alien. "Get me the president," he said quietly, "and start buying every roll of kitchen foil on the continent." The next 72 hours were going to be the strangest in the history of human military logistics. And they were going to happen faster than anyone thought possible, because the Xylo's fleet had just entered the inner system and the clock was running out. The global foil operation had no official name in its first 24 hours. Field teams started calling it Operation Baked Potato almost immediately, and despite 3 separate attempts by Pentagon communications staff to introduce something more dignified, Baked Potato is what stuck. It was one of those names that was too accurate to suppress. The operation ran around the clock across 14 time zones. Emergency procurement teams fanned out across North America, Europe, Australia, and Japan, descending on restaurant supply warehouses, commercial kitchen equipment dealers, hotel storage facilities, and food manufacturing plants. They were not subtle about it. Every available roll of heavy-duty aluminum foil on the planet was being bought, requisitioned, or commandeered at government rates, loaded onto military transport aircraft, and flown to the 7 naval bases where the 4th Fleet was anchored in low Earth orbit. The reaction from the High Command was not uniform. Admiral Richard Harmon, commander of the 4th Fleet, had 31 years of service and a reputation for being the most tactically innovative flag officer in the United States Space Navy. He had also, upon receiving his briefing on Operation Baked Potato, gone completely silent for approximately 45 seconds before saying, in a very measured voice, "You want to wrap my warships in foil." Like turkeys, Daniel Reeves had flown to Harmon's command station personally. He'd brought Carolyn Marsh, Stephen Ward, and Marcus Holt. He'd brought the test footage. He'd brought the physics briefing. He'd brought the full spectroscopy data from 17 separate trials at 3 different power levels. And when he was finished presenting all of it, he'd looked at Richard Harmon and said, "Yes, like turkeys, and I believe it will work." Harmon had stared at the data for a long time. He was not a man who made decisions based on optimism. He made them based on evidence. And the evidence in front of him, the evidence that crinkled kitchen foil scattered a thermal lance beam into a useless light show, was the best evidence he'd seen in 14 months of looking for. A way to save his fleet. "How long do we have?" Harmon asked. "Xylo's fleet will be in weapons range in 71 hours, Daniel said. "We need to have every ship wrapped and ready in 50. Harmon looked at his chief of staff. His chief of staff looked at the logistics projections. Then he looked back at Harmon and gave a single, slow nod. "All right," Harmon said. "Let's go wrap some turkeys." The wrapping operation was unlike anything in the history of military logistics. 7,000 personnel worked in rotating 12-hour shifts across the fleet anchorage at L2 Station, applying foil to the hulls of 38 warships in conditions ranging from comfortable to genuinely dangerous. The foil arrived in bulk shipments, enormous compressed bales that had to be sorted, cut to hull section specifications, and applied by teams working in pressurized suits on the exterior of ships that were never designed to be worked on this way. Marcus Holt was everywhere. He'd barely slept in 4 days. He moved from ship to ship in a constant loop, checking adhesion quality, verifying crinkle patterns, troubleshooting problem areas where the silicone bonding compound wasn't curring correctly in the thermal shadow of certain hull geometries. He yelled a lot. He also solved a lot of problems with solutions that would have seemed insane in a peacetime engineering environment, using modified welding tools to create localized microcrimping in foil sections. That had gone too smooth. Improvising backing layer patches from scavenged thermal blanket material when the perforated substrate ran short. The crews wrapping the hulls were mostly not aerospace engineers. They were Navy ratings, maintenance technicians, and volunteers drafted from support staff who'd never worked a hull mount operation in their lives. Marcus trained them in 30-minute sessions and then turned them loose, checking their work in rounds. The quality was uneven. Some sections were beautifully applied. Others were rushed and slightly ragged. Marcus had stopped caring about beautiful 2 days ago. Ragged was fine. Ragged was actually better. Ragged meant more random microfacets. Ragged meant more scattering. Don't smooth it out, he told every crew he passed. The uglier the better. If it looks wrong, you're probably doing it right. Captain James Calloway, commanding officer of the destroyer UES Relentless, stood on his observation deck and watched his ship being wrapped with the expression of a man attending a funeral he didn't quite understand. Relentless had been his command for 3 years. She was a beautiful ship, sleek, dark, precisely engineered, built to move fast and hit hard. She was currently being encased in dull, crinkled, slightly lopsided aluminum foil by a crew of 18 people who kept dropping rolls in zero gravity and having to chase them across the hull. His executive officer, Lieutenant Commander Patrick Hughes, came to stand beside him. "She looks ridiculous," James said. "Yes, sir," Patrick agreed. "Tell me the science works." "Doctor." Marsh says 93% confidence at tested power levels. The Shepherd can't lock on to the surface geometry. The beam scatters before it can establish resonance. James was quiet for a moment. 93%, he repeated. "Yes, sir. What about the other 7%? Patrick didn't answer immediately, then carefully, "Doctor." Marsh says the other 7% is mostly edge cases, involving sustained multi-angle fire with automatic full profile adaptation. She says the Xylo's AI would need approximately 4,000 targeted firings at a single ship to begin developing a viable model, assuming the ship wasn't maneuvering and the foil pattern wasn't being varied in real time. James nodded slowly. "So as long as we keep moving and keep the foil rough," James looked at his ship. Then he looked at the stars beyond L2 station, at the precise region of space where the Xylo's fleet was currently making its approach at a velocity that, translated into human terms, felt like watching a freight train come at you in slow motion and not being able to step off the tracks. 71 hours, now 68. "All right," he said. "Let's make sure we're the ugliest ships in the galaxy." What nobody in the fleet knew yet, what only Daniel Reeves and a handful of senior command staff knew, was that the Xylos had accelerated their timeline. The fleet wasn't 71 hours out anymore. The new estimate, updated 3 hours ago by the Deep Space Tracking Array, was 44 hours. And 16 of the 38 ships in the Fourth Fleet were not yet wrapped. The last 16 ships got wrapped in 31 hours. Nobody slept. Nobody stopped. Marcus Holt stopped speaking in full sentences and communicated entirely in gestures and specific technical instructions, his voice having given out somewhere around hour 26. Patrick Hughes ran a relay system, ferrying messages between Marcus and the hull crews in a continuous loop. The foil went on rough and fast and uneven, and Marcus signed off on every section personally because there was no time for anyone else to make the call. The Xylo's fleet came into visual range on a Thursday morning, Earth time. They appeared as a cluster of points of light that grew steadily brighter against the star field, 17 capital ships, each the size of a city block, flanked by dozens of smaller assault vessels. They moved with the unhurried precision of something that had never encountered a problem it couldn't solve. In 14 months of conquest across the outer system, nothing had slowed them. Nothing had stopped them. Nothing had even surprised them. Admiral Harmon watched them come from his flag bridge aboard UES Resolute, the largest ship in the Fourth Fleet, and the first one fully wrapped. Resolute looked extraordinary from the outside. She had always been an imposing vessel, massive, dark, bristling with weapon systems. Now she was massive and shimmering faintly in the sunlight, every surface covered in crinkled aluminum that caught and scattered light in constantly shifting patterns. She looked like someone had tried to wrap a skyscraper in gift paper during an earthquake. "Fleet status?" Harmon asked. "All 38 ships reporting wrapped and sealed," his communications officer said. "Marcus Holt is requesting permission to go sleep somewhere." "Granted," Harmon said. "Send him my personal commendation and a blanket." The Xylo's fleet stopped its advance at a range of approximately 800,000 kilometers, close enough for their sensors to conduct a full analysis of the human fleet. Standard procedure before weapons engagement. The Shepherd would be scanning everything right now, building profiles, calculating resonance frequencies, running its predictive models, preparing targeting solutions. The fleet held there for 11 minutes. Daniel Reeves, watching the same data feed from the Joint Command bunker on Earth, found those 11 minutes to be the longest of his life. The room around him was completely silent. Nobody moved, nobody spoke. Everyone understood, without needing it explained, that what was happening 800,000 kilometers away was a machine intelligence trying to do something it had always been able to do, and either succeeding or failing, and that the result of that success or failure would determine whether the human race continued to exist as a free civilization or became a processed resource in an alien empire's expansion ledger. 11 minutes, then 12, then 14. "They're not firing," Stephen Ward said quietly from across the room. "Not yet," Daniel said. At minute 17, the Xylos fleet fired. Every capital ship discharged simultaneously, a coordinated volley that, at the range and power levels involved, should have destroyed the entire Fourth Fleet in under a minute. The beams crossed the distance at the speed of light and hit the human ships in the same instant they left the Xylos emitters. From the deep space observation platforms, the moment of impact looked like someone had thrown 17 spotlights at a collection of disco balls. The thermal lances hit the foil-wrapped hulls and shattered. Every beam that touched a crinkled surface fractured into hundreds of reflected fragments, spraying energy in random directions across a 360-degree sphere. Some fragments hit other ships, but hitting aluminum foil was no different than hitting the first ship. They scattered again, the energy diffused. The resonance cascades never triggered because the Shepherd's targeting lock never completed. Every time the AI tried to resolve a surface geometry and find the molecular resonance frequency, the chaotic microfacet structure of the crinkled foil defeated the calculation. The human fleet was surrounded by a constantly shifting, completely unpredictable scattering field. The Xylos beams didn't bounce off it. They didn't reflect cleanly. They were destroyed by it, their coherent structure shattered into harmless chaos by surfaces that were too random to target and too irregular to model. From inside UES Relentless, Captain James Calloway saw the engagement as a flash of prismatic light across every observation port simultaneously, a brilliant, multicolored display. Like the world's most aggressive light show, and then nothing. No impact, no hull breach, no alarms, just light everywhere and then the ordinary darkness of space. "Report," he said very quietly. "Zero hull impacts," Patrick Hughes said from the damage control station. His voice was slightly unsteady. "All systems nominal, the beams hit us and..." "They just went everywhere." James looked at his hands for a moment, then he looked up. "Return fire," he said. The Fourth Fleet's conventional weapons, railguns, missile platforms, directed energy cannons operating on standard electromagnetic principles that the Xylos had no particular defense against. Because no one in the galaxy had previously been insane enough to fight them head-on, opened up in a coordinated salvo that Admiral Harmon had spent 3 weeks planning. The Xylos had never needed to develop defensive countermeasures against weapons they expected to eliminate before they could be used. They didn't have energy shields designed to stop railgun slugs. They didn't have point defense systems fast enough to intercept the Fourth Fleet's missile packages at close range. Within 6 minutes, 4 Xylos capital ships had sustained critical damage. One was destroyed entirely when a lucky railgun salvo penetrated its unshielded reactor containment. The Xylos fired their thermal lances again and again, 17 more volleys, each one producing the same beautiful, useless light show as the first. The Shepherd adapted its targeting algorithms after each firing, learning, adjusting, trying to find a solution. It didn't find one. Every adjustment it made produced a different version of the same failure. The crinkle patterns were too varied. The microfacet geometries across 38 different ships, applied by hundreds of different human hands in different ways, created a dataset so diverse that the Shepherd's convergence models couldn't stabilize. The AI was doing exactly what it was built to do. It was learning from every shot. It just needed approximately 4,000 more firings to build a viable model, and humanity wasn't planning to give it the time. The battle lasted 43 minutes. When it ended, 11 Xylo's capital ships had withdrawn at maximum velocity on a course out of the inner system. 6 capital ships and 14 assault vessels were destroyed or disabled. The Fourth Fleet had lost 2 ships, both from a sustained multi-angle volley in the final minutes when the Shepherd had managed to partially adapt its model for those specific vessels' foil. Configurations. 41 crew members. It was the first time in the Xylo's Empire's recorded 3,000-year history that it had lost a fleet engagement, and it had been beaten by kitchen foil. Daniel Reeves sat in the silence of the Joint Command Bunker for a long time after the engagement data came in. Then he picked up his coffee cup, found it empty, set it back down, and said to the room at large, "Someone please tell me we bought more foil." The Xylos didn't come back, not immediately. Not for 3 months. And when their second fleet arrived at the edge of the solar system, it stopped at a distance of 4 million kilometers, well outside engagement range, and held there for 9 days. Running sensor sweeps. Trying to understand what it was looking at. In those 9 days, Earth didn't wait. Operation Baked Potato had become, in the weeks following the Battle of the Mirror, the name that military historians almost immediately settled on. Because the engagement footage showed something that genuinely looked like humanity had turned space into a hall of mirrors, the largest materials logistics operation in human history. Every warship in the combined Earth Defense Fleet was being wrapped. Production lines at Reynolds, Amerifil, and 6 overseas manufacturers were running at maximum capacity, 24 hours a day, turning out heavy-duty aluminum foil at a rate that would have seemed completely unhinged in any other context. The global aluminum market had, briefly, gone completely insane. Marcus Holt had slept for 14 hours after the Battle of the Mirror. Then he'd woken up, eaten an enormous breakfast, and immediately gone back to work because there were still problems to solve. The foil application process needed to be systematized. The bonding compound needed refinement for different hull geometries. There were questions about long-term durability in deep space thermal cycling, about maintenance procedures, about what happened to the scattering properties when the foil sustained micrometeorite impacts over extended deployments. Marcus worked through all of them methodically, building a technical manual that would eventually be translated into 12 languages and distributed to every fleet in the Earth Defense Initiative. He was given the National Medal of Technology and Innovation 6 months later. He gave a short, slightly uncomfortable acceptance speech and then went back to Nevada. Dr. Carolyn Marsh was appointed to lead the newly formed Galactic Materials Warfare Research Division at Lawrence Berkeley, with a budget and a staff that would have seemed impossible a year earlier. She spent the next decade developing what became known as chaos reflective shielding, a discipline that started with crinkled kitchen foil and eventually produced engineered surfaces with mathematically optimized random geometries. Surfaces that could scatter coherent energy beams with near-perfect efficiency, while maintaining structural integrity through years of deep space operation. The kitchen foil was the proof of concept. Carolyn built the science. Captain James Calloway was promoted to Rear Admiral following the Battle of the Mirror. He took command of the newly commissioned 3rd Deep Space Battle Group, which was, in his words during the commissioning ceremony, the ugliest collection of warships ever assembled. And I have never been so proud of anything in my life. Admiral Richard Harmon retired 18 months after the battle with full honors and the quiet satisfaction of a man who had made one genuinely insane decision at a critical moment and been completely vindicated by events. In his retirement speech, he said only, "I want it on record that I was not the one who called them turkeys. That was General Reeves." And he was right. General Daniel Reeves, promoted to full general in the immediate aftermath of the battle, spent the next 5 years overseeing the transformation of Earth's defense posture. The Xylo's second fleet, after 9 days of sensor sweeps, had eventually retreated. 3 months after that, the first of what would become known as the Scatterfield Protocols was transmitted to the Xylo's Empire via the diplomatic frequency they'd established after first contact. It was short. It contained the technical specifications for chaos reflective shielding. It contained the engagement data from the Battle of the Mirror. And it contained a single sentence at the end, which Daniel had written himself. "We have more foil than you have time." The Xylos did not respond for 4 months. When they did, it was through a channel they had not previously used, a low-frequency carrier signal that the Lawrence Berkeley AI identified as a negotiation band transmission. The message took 3 weeks to translate fully. The short version was, the Xylos Empire was prepared to discuss terms. Nobody wanted to celebrate prematurely. Diplomacy with a 3,000-year-old empire that had previously shown zero interest in coexistence was not a simple process, and Daniel Reeves was not a man given to premature optimism. But something had shifted. The Empire's fundamental strategic calculus, the calculation that resistance was futile, that compliance was identical to resistance in outcome. That processing was inevitable, had encountered a variable it hadn't accounted for. And that variable was the human tendency, when backed into a corner with nothing left to lose, to start looking in garbage bins for answers. The irony was not lost on anyone. The Xylos Empire had spent 3 millennia and trillions of resource units perfecting the thermal lance, an instrument of such elegant, precise, terrible power that it had simply never encountered a surface it couldn't destroy. And it had been defeated, not by a superior technology, not by a more advanced civilization, not by some exotic physics principle that humanity had developed through centuries of research. It had been defeated by the accumulated chaotic geometry of human hands crumpling aluminum foil in slightly different ways. The galaxy was vast and political and full of civilizations that had been doing things the same way for so long that they had stopped being able to imagine any other way. The Xylos had never lost because no one had ever been desperate enough, or creative enough, or human enough to reach into a recycling bin and say, "Wait, what if we use this?" In the mess hall of UES Relentless, someone had framed a single sheet of crinkled aluminum foil and hung it on the wall with a small brass placard underneath. The placard read, "The most dangerous weapon in the galaxy. Do not underestimate what a human will do with garbage." It stayed there for the rest of the ship's service life. Officers from other fleets came to see it on port visits. Some of them laughed. Most of them took photographs. All of them understood on some level that it wasn't really about the foil. It was about the 48 hours of desperate, sleepless, half-insane human ingenuity that stood between the foil and the fire. It was about Marcus Holt chasing a roll of foil across a warehouse floor at 2 in the morning because there wasn't time to order more. It was about Carolyn Marsh crouching on the floor of a recycling facility and seeing not garbage, but geometry. It was about Ryan Blake pointing a spectrometer at something nobody had ever thought to point a spectrometer at, and paying enough attention to notice when the readout went wrong in exactly the right way. It was about a species that, at the moment of its greatest crisis, had reached into the trash and pulled out a victory. Here at HFY Endurance Tales, that's the kind of story we live for. If this one hit different for you, if you felt that moment when the foil scattered the first beam and realized what humanity had just pulled off, drop a comment below and tell us your favorite part. Share this with someone who needs a reminder that human ingenuity doesn't come with a power rating or a price tag. And if you haven't subscribed yet, now is the time because we've got more stories like this one and they only get better. The galaxy underestimated us. It won't make that mistake again.